Hi, welcome to Lesson 5 or Section 5 in our chapter on polynomials. Today we're going to add a couple more tricks for finding zeros of polynomial functions, and the tool that we're going to use today is called the rational root theorem. If you look at the statement of this theorem, it looks kind of odd. If f of x equals, and then there's all this algebra, but ladies and gentlemen, that's just displaying what a polynomial function looks like. Constant times x to some power. It's arranged in decreasing or descending powers of x until we get to the very last thing, a constant. That's just saying if you have a polynomial function, then if it's going to have rational zeros, and rational numbers, you remember, are just part of the real numbers, things that can be written in fractional form. If it's going to have rational zeros, they have to be in the form p over q, where p is the constant term, so here, and q is the leading coefficient, so right there. It sounds weird. I need to put it in words that I can understand. So in layman's terms, if a polynomial is going to have any rational zeros, if a polynomial is going to have rational zeros, then they will be factors of its constant divided by leading coefficient. Alright, let's see if we can see how that will play out. If a polynomial is going to have rational zeros, then they will be factors of constant over leading coefficient. So, a quick reminder that the rational zero theorem or rational root theorem does not tell you what the zeros are. It just gives you possibilities for zeros that might be rational numbers. In fact, many polynomials don't have rational zeros, so this won't work every time, but at least it gives you a place to start looking for what might be a zero in a function. It says that we should find the possible rational zeros of this particular polynomial, and we know that if they're going to occur, they're going to be some factor of, and it is constant over leading coefficient, constant over leading coefficient. In this case, that's -6 over 1. So they're going to be things that will multiply to make -6. Our possibilities would be positive and -6 could be roots or zeros for this function. Positive or -1. The only other rational things that can come up are plus and minus 2 and plus and minus 3. Those are the only possible rational zeros for this function. Now, in just a few minutes, we're going to see about how you can use those possible rational zeros to start breaking down a polynomial. But here's one for you to try. The possible rational zeros of, and it's x cubed plus 8x squared plus 11x minus 20. So the constant is -20, the leading coefficient is 1, and we would be looking for factors of -20 over 1. Well, those would be plus and minus 20, plus and minus 1. Other things that multiply to make 20, 2 and 10, 4 and 5, and I just got to think, have I left any out? 20 and 1. Nope, I think we've got them covered. So that's a lot of numbers to have to check if you're looking for your first zero, but if there are going to be rational zeros, it's going to be one of those possibilities. So to decide whether those possibilities are zeros, what you have to do is divide by them. So you're going to use that synthetic division. Synthetic division. Let's see how that plays out. we have an example problem here. Once we know the zeros in the third degree polynomial, we can use the quadratic formula on the depressed polynomial. And you'll remember that that is which is found by looking at the bottom row in the synthetic division. Bottom row after synthetic division. All right, so all the zeros of this cubic are what we're looking for. Well, this one is kind of sweet. All the possible zeros, if they're rational, are multiples or things that multiply factors of -2/1. -2 is the constant, 1 is the leading coefficient. And really, there are just a few choices here, positive or -2, positive or -1. Now, I'm not sure which of those work, but I can tell by using synthetic division pretty quickly if one does. So I'm going to start up here. I'm going to start with my coefficients in the polynomial, -5 and -2. I'm going to think, okay, I'm not sure which of these work, but I'm going to use 1 to start with, +1, and see what happens. So I drop the first one. 1 times 1 is 1, that's 2 when you add. 1 times 2 is 2, that's -3. That's -3, and that is not 0. So, nope. This is a no. All right. I'd like to try 2 next. So 1, 1, -5, and -2. And I want to see if 2 is a rational 0. So I drop the 1 down, and now multiply, and now add. And multiply and add. Hey, that one's working out. 2 is one of the zeros. All right, so I'm going to write my final answer up here, and I know the first 0 I found is 2. Now I have this thing which leads me to a quadratic. I need to find or solve this quadratic equation. It's 1x squared plus 3x plus 1. Remember, the exponent here is 1 less than where you started. 1 less than where you started because you've already divided out 1 power of x. This is not going to be a factorable one, so it's going to be a quadratic formula problem. X will equal the opposite of b over 2a plus or minus, it's the square root of b squared, so 3 squared is 9, minus 4 times 1 times 1 all over 2. And moving on out this way, that's -3/2 plus or minus 9 minus 4, square root of 5 over 2. That can't be simplified anymore. So we have found our 3 zeros. -3/2 plus root 5 over 2 and -3/2 minus root 5 over 2. Now, as you can see, this technique works really well. It's nicer if you have a limited number of possibilities, of course, but it can be used to find any rational 0 in any polynomial. So at least that gives you a place to start, right? You have some things, some values that you can check out, and once you find one of them, then finding the others is a matter of using the quadratic formula. So I'm going to say that's the end of our lesson today. Our next class period will be working with this, finding zeros of polynomial functions. So try that, you try, and we'll see you at the next class period.